So really excited today to talk to you about what we believe is the biggest evolution of vSphere in the past decade, what we're calling Project Pacific. Did everyone see the keynote this morning? Out of curiosity? Okay, so you got a little bit of a clue as to what we're talking about here. But as the slide shows, it's really about how do we bring together vSphere and Kubernetes to do something really, really innovative and pretty ambitious. And so we're really excited about it, and so let's just jump right in and talk about it. We'll definitely have some time for questions at the end, and we got a whole team that's actually worked on it right here. So they're the technical experts. You know, I'm a CTO, Chief Talking Officer, so I can only do so much. If you want the real answers, you got to go over there. Okay, so let's get into it. So, the context for this is really, we spent a lot of time over the past few years looking at where modern applications are going. And there's this stat that we tend to use a lot around how there's going to be more apps provisioned or created, I should say, in the next 5 years than there were in the past 40. It's pretty astonishing, right? Talking about hundreds of millions of workloads here. And these workloads are going to look very different than they traditionally have. Right? There's going to be many more of them, smaller, more distributed, more data-centric, using all sorts of new capabilities such as AI. By the way, for folks looking for seats, there's still some here in the front if you want to come up. Don't feel shy. And so, these apps, the nature of the application is fundamentally changing. And if we take a closer look at what an application really looks like, when you think about a modern app, people tend to think about, oh, I've got a pod or a container running inside of Kubernetes. That's cool, right? And certainly that is a modern app, but what we find is that that's typically only part of a holistic application. Because of course, first of all, you have a cluster running there. You got to manage the nodes. You got to think about that somewhat more holistically. And there's of course a lot of existing applications in your environment of various shapes and forms. And those things have a lot of functionality that new application or application component needs to talk to. And oftentimes, that application component is relying on some external database for persistence, a canonical store of data for that environment. And then you may have even some other types of things happening, such as serverless and function as a service. So this is really what a modern application starts to look like, right? It's not 100% new, cool, cloud-native, distributed. It's some of that, but it's a lot of what you already have as well. And it's diverse. It's heterogeneous. You look at these different boxes here with these different types of apps, and what you often find is that sometimes there's different tooling, different teams operating them, different infrastructure even, different processes. And that creates a lot of challenges. Challenges for both the development team as well as for IT operations, as you can well imagine. And the developers have a certain point of view. They're looking at how can they move quickly, how can they get access, self-service access to the resources they need to iterate on their application, to get the job done, to get that thing out in whatever business-driven time frame that they need to do it in. On the IT operations side, of course, there's a lot of thinking around, okay, how do I drive compliance and security? How do I think about availability, right? What does availability even mean in this very complex application? If my database starts having some issues, is that going to affect the app running inside of Kubernetes? And how do I actually debug that and figure these things out? So a lot of this complexity is there. And so this is the context into which we've been thinking. How can we help? What can we do to drive a lot of this? And when you look at it, where we wanted to get to, conceptually, was this picture here. This notion of, hey, how can vSphere be this common platform for operations and developers to come together, to unite them, to work together across these many different tasks which they need to do? Developers, of course, looking at how they can move as quickly as possible at iterating, building building applications, getting the new version out. Operations at the same time making sure they can do that safely, do that in production with all the different production-grade capabilities. We've got a lot of the pieces for that today in vSphere, but how do we really take it forward? And the thinking was, hey, what if we could use Kubernetes to help us here? vSphere's got a lot of strengths, especially for existing apps. There's a great ecosystem around vSphere, thousands of partners, all sorts of cool technology. Kubernetes, on the other hand, has got a lot of modern apps, a lot of evolving ecosystem people in there doing a lot of interesting things. So how can we bring them together? And how can we leverage Kubernetes as an infrastructure interface? Well, let's take a look at this application. So again, I talked about how different it is, how these apps are deployed, like what are the tools being used? Is VRA being used for all this, or is it some Puppet and Chef, or is it something else entirely? What if you could actually specify this application using Kubernetes, all the different pieces of it, right? From that cluster with the pods running inside of it, to even the this legacy VM that you have, specifying that with Kubernetes. And now what you'll see here is, I don't know how familiar people are with Kubernetes, but in the upper right-hand corner, what we see is a spec for this legacy existing application. And what you can see is the type or kind term there. It's a virtual machine. What if we could actually manage virtual machines using the Kubernetes interface? Because this interface is very powerful. What this thing is here is a declarative specification. Declarative meaning, this is the way I want the world to look. When this app gets provisioned, here's the things I want to be true. How you do it, well, you can figure that out in infrastructure, right? But I just want to tell you what I want, right? So that's a really powerful interface and abstraction that Kubernetes has. So let's take advantage of that to simplify how we manage VMs. But not only that, we can do it for serverless, right? This is a lot of established stuff today in the Kubernetes world. But we can even think higher level. Rather than thinking about individual VMs or pods, what if you can actually model a database as a first-class object within Kubernetes? Like, this is not just a random collection of 3 VMs. This is actually SAP HANA. It's a HANA database type. And now we can start doing some even more interesting things. So what's cool here is that you have all these different application components, some old, some new, and yet we can use Kubernetes as a lingua franca here across them all to manage them and specify how we want them to be deployed and configured. Moreover, there is a concept within Kubernetes called a namespace. A namespace is like a lightweight form of tenancy. It's a way of divvying up a Kubernetes cluster and providing different isolation in terms of resource, security, access, etc. Can we leverage this namespace concept from Kubernetes to actually manage an application more holistically? Could we actually put all these different components that we have here inside of that namespace and then apply policies on that namespace such that each of the components that are running within there automatically inherit those policies? So this is cool. Now you can think about this, right? In this structure, IT operations can really manage that namespace. They can set policy. They can set resource policies, storage policies, security policies. While the developer has access to that namespace, they can use Kubernetes and the native Kubernetes tools, command line tools, kubectl, etc., to provision workloads inside of there. And those workloads, again, will naturally inherit all those properties. So the idea is, again, it's best of both worlds. We give IT operations and admins what they want, these control points, while at the same time enabling developers to go as quickly as they want. And that's exactly what we're doing with Project Pacific. So the idea here fundamentally is that we are re-architecting vSphere with Kubernetes built in. As Joe talked about this morning, this is not some sort of like superficial thing. We're kind of just layering it on top. Not at all. This goes Kubernetes to the core inside of vSphere, right? A lot of work went into this. Pretty much every major subsystem of vSphere has been affected and been touched by this effort here. A ton of engineers working across this for quite a while. And I'll get into some of the technical specifics here, but there's a lot of really interesting things about what we're doing with Kubernetes and how we're leveraging that. But what's important to know about Pacific is that it's not just about Kubernetes. It's also about how do we enable IT operations to manage at a higher level of abstraction. Again, we talked about that number of like 500 million workloads or whatever it is coming into existence for the next 5 years. And that sort of scale means you can't manage how you have before. Right? You can't manage each of these individual VMs or pods by itself. Instead, you got to think more holistically. How can you manage this thing at an application level? So that's another big focus of Pacific. And finally, developer and IT operations collaboration. Right? This is, again, another really, really important aspect here. And one of the things that is cool about what we have done with Pacific is that when a VI admin or an IT operations person looks at it, they see vSphere. And yet, when a developer looks at it, they see Kubernetes. And yeah, it's the same thing underneath the covers. And so by ensuring that and making that real, both these sides can now actually be talking about the same thing, even though they use slightly different terms and maybe think about it a little bit differently. Underneath the covers, it's all the same, which is really awesome. And you can see there's a whole bunch of benefits to this model as well, right? Improved economics being a huge one. You don't need to reinvest in a whole new team, whole new training, whole new tools for these different parts of that application. You can manage all that application centrally on top of vSphere, right? You get control at scale with this app-focused management, this ability to manage a whole bunch of complex things in a straightforward way. And finally, increased velocity, right? Once we get developers and IT working better together, we allow that model of self-service to really take effect. We can get speed and control, security, etc. Okay, so let's talk more about what we're doing here with Kubernetes. So we are really embedding Kubernetes in multiple layers here. So let's talk about a few of them. Well, let's start off with our supervisor cluster here. So what we've done very concretely is made it such that each ESX cluster is now also a Kubernetes cluster. We call this a supervisor cluster. And within the supervisor cluster, this, you can give access, IT operations give access to developers to provision workloads inside of there. And again, those workloads can be VMs or pods or even entire other Kubernetes clusters. I'll talk more about that in a minute. So, when Kubernetes in this cluster wants to do scheduling, it has, there is a scheduler inside of Kubernetes, but what we've done is made it call out to DRS and leverage DRS to do scheduling. When that process actually is going to run on ESX, instead of using the traditional VM runtime, we have an optimized runtime that Joe talked about this morning that we call vSphere native pods. And the idea there is that all we're doing is running a container. We don't need the full 100% physical machine compatibility that we traditionally had to have with virtual machines, right? Because we didn't know what sort of app was running, what the operating system needed to do. We needed to support everything just like a regular physical host. In this environment, because it's a container, because it's Linux, we can take a lot of shortcuts. We don't need to boot a BIOS. We don't need to set up ACPI tables. We don't need to do any of that stuff. We can just load that binary image, load the executable code, and jump right into it and start executing the process. So it loads very quickly. But moreover, what we found is that by doing this, and because of the fact that ESX has a very fast and very efficient scheduler, we can get performance improvements both over traditional VMs as well as bare metal, as Joe talked about this morning. So as you saw this morning, we had this big giant slide with these stats. And one of the ones we showed was we're actually, in this model for compute-bound workloads, 8% faster than bare metal. And of course, we got a lot of questions. Well, how does that even work? What you find is that CPU virtualization in the hardware is basically zero cost now, very low, right? And so then it becomes a question of who has a more efficient scheduler. And it turns out ESX actually does some really, really cool scheduling things across NUMA nodes, which allow for better and more efficient use of the processor, making these things faster than bare metal. So it's kind of some crazy stuff. So as you can tell, lots of integrations really across the board. And the idea there is to take the best of both worlds. How are we taking the best of Kubernetes with the best of what we have with vSphere? App focus management. So the idea here is how can we start specifying policies at a higher grain level, right? The idea is instead of having to specify a policy for every workload that a developer might provision, let's do it once and do it at the application level. So specifically what we're talking about here is we are leveraging a Kubernetes namespace, and you can manage that namespace as a first-class object, as an application. So the IT operations team can provision out namespaces to developers or to developer teams, and then they can set policies on that namespace, and all the workloads the developer happens to self-service provision into that namespace are inherited. So this is really cool, and I'll show some screenshots here in a minute, but you can imagine things like resource management policies, leveraging all the great resource management controls we have in vSphere, storage policies, so on and so forth that you can set and that all the workloads then can inherit. We also want to be able to do bulk actions on this application, right? So if you think about vMotion or DRS, how do you manage that across all the applications or the components in that app at once, or snapshotting or something like that? The other really cool thing, and this is something that you can see here on the screen, is that you can now see Kubernetes inside of the vSphere client. So one of the challenges that we've had before is that when you would provision a VM, let's say as part of a Kubernetes cluster, you could see that VM inside the vSphere client, but you couldn't see what's inside the VM. Like, oh, that's actually a Kubernetes cluster VM. You didn't know that unless it's named a certain way. But even if it was named a certain way, you couldn't really see the pods that were running inside of that VM, right? You could just see there was a VM. And so what we're really enabling now is that deeper level of visibility. So you can get visibility into all the different pods that are there and different apps that are running. And then you can actually take action on them as well. You can manage them as first-class citizens inside of vSphere using all the great vSphere tools and technologies. So really, really cool stuff there. So the final one, of these three we talked about, dev and IT ops collaboration. Now, I mentioned earlier on this idea of using Kubernetes as an infrastructure interface. Typically speaking, when people have thought about Kubernetes, it's as a container orchestrator. The point of it was to create an environment to run containers. But Joe Beda has talked a lot about this concept that Kubernetes is actually much more than that. The term he's used is it's a platform, i.e. a platform used for building other platforms. Kubernetes was designed to be extremely extensible, and we've leveraged that extensibility here. And so the way you can think about this is that vSphere now has two primary APIs, one of which is our traditional VM-based API, the other one is a Kubernetes API. And that Kubernetes API can be used by the developers, lines of business, users, etc., as an workload management interface into vSphere. And the idea here is, again, they can manage all their workloads, including VMs, using this thing. So that's what I said before. When a vSphere admin looks at it, they just see vSphere, right? That's what they're used to. And now it's been extended with some cool Kubernetes stuff. And when a developer looks at it, they say, oh, this is Kubernetes, right? Now it's got all this cool vSphere stuff in it. I can run VMs. I can create a whole other Kubernetes clusters. And again, that drives that sort of consistency that we talked about before. Okay, so now let's go to the next level of technical detail here. So again, kind of like going iteratively one level down. You're familiar with this picture. It's just a normal ESX cluster. Now, how does this change with the addition of Project Pacific? So we're doing a couple of things. As I said, each ESX cluster now also becomes a Kubernetes cluster. In Kubernetes lingo, there's a thing called a kubelet. A kubelet is what runs on a Kubernetes worker node. And a kubelet, kind of like if you're familiar with Hosty, its job is to talk with the controller, in this case the Kubernetes master, and issue commands and so forth on the local host. So what we've done is we have a kubelet, we call it a spherelet, because we've modified it a bit for vSphere, and that runs right next to Hosty on that physical host. And we also have a set of Kubernetes masters running within the cluster as well. So this is a basic Kubernetes architecture. And as you can see here, again, vCenter has an API to that cluster. You can provision VMs, whatever you want. Kubernetes also has an API out as well, and that's what you give to your developers. And so they talk directly into that Kubernetes master. Okay, so first thing, you can provision pods here. Again, these pods run natively inside of ESX. The whole concept of Kubernetes is that, that when you run a pod, it just runs within the Linux operating system in which that kubelet is running. So we had to create something similar here, right? We don't want to fire up a full Linux VM necessarily every time, or you can balance multiple containers, multiple pods per VM. What we do instead is leverage a lot of the technology that we've been using in the past. If you're familiar with vSphere integrated containers or Project Bonneville, some of that early work, this notion of let's dynamically create a VM that's just right sized for this workload on the fly and optimize it for that workload. So again, so it's actually a new runtime here we're calling CRX. So if you're familiar with some of the VMware or vSphere internals, we had something called a VMX. A VMX is what runs guest operating systems, the use level portion of it. And now we want to do something called a CRX. And the idea of a CRX is that it's an optimized runtime specifically for containers. As I said before, this thing is not supposed to emulate a full physical machine. Its job is to run a container as securely and efficiently as possible. It still leverages Intel VT and the hardware level virtualization mechanisms, but it's a bit closer to a process than to a virtual machine. So some really interesting innovation down in the depths of ESX there. So you can provision as many of those pods as you want. As we said, DRS can take over and schedule them intelligently using all the great functionality that we have there. Now, you can actually run VMs as well here. I've mentioned this a few times, but this is a really important point. Let me spend a little bit of time on it. So in this environment here, again, the developer is using this Kubernetes interface. They can specify a new type of pod, and we call it just a VM type. And that VM can literally be just a normal VMDK, right, that we've converted into a container image. So there's not actually any work that you need to do to migrate your applications except changing the container image, the image file format. So this is really great because it means you don't have to go through the expensive re-architecting, refactoring, or whatever else you might need to do to get this thing to run in Kubernetes. Usually there's some work there. But here you can do it at basically very low to zero cost. Now, why would you want to run a VM inside of Kubernetes? Well, it goes back to the first point I made, that first of all, you get consistent management of all these things. You get those Kubernetes ecosystem benefits. You get a declarative specification that we talked about before. But you get a lot of other things too. You can store it in a container registry. You can now store all your applications in a container registry. You can manage them centrally there. You can audit access to them. You can use a bunch of other great container ecosystem features, things like CVE scanning. You can now automatically CVE scan all the different containers, both regular containers and full VMs, that live in that registry. CVE scanning, by the way, looks for known vulnerabilities, so you're not provisioning malware or other sorts of issues into your data center. You can then cryptographically sign those containers, again, those VMs, and to prove where they came from and that nobody's manipulated them. These are all functionalities that exist out in the container ecosystem. These are great things to take advantage of. You can also enforce that in this vSphere cluster here, only signed images are allowed to run. So the cool thing about this is that you can start getting a lot of container benefits without doing all the work of refactoring. I talk about it very similarly to customers' experience with VMware Cloud and AWS. You can literally vMotion a workload into the cloud, into an AWS data center, without modifying it at all. Now, of course, to modify, you can get better scalability and things, but even without that, you get a lot of cloud benefits for zero work. And here again, you get a lot of Kubernetes and container ecosystem benefits for zero work. And so the cool part about this, when we looked at it, was like, oh my goodness. We got 400,000, 500,000 vSphere customers, about 70 million workloads running in VMs today on top of vSphere. All those things overnight can now be Kubernetes workloads. That's pretty powerful. And so we can actually move forward all of our customers' fleets of applications with very, very little effort. So really, really powerful stuff here. Now, on that, this VM actually becomes a really interesting thing, because it's not just about running regular VMs with applications in them. You can put anything inside a VM. You can even put another Kubernetes cluster inside of a VM. And so let's say those two green VM boxes there, those could actually be running two different Kubernetes worker nodes. And so this is a distinction we have between what we call a supervisor cluster and a guest cluster. And I'll talk more about that here in just a minute. But this essentially is the supervisor cluster. A supervisor cluster is a Kubernetes cluster. It is also a vSphere ESX cluster. It is both of those things together. And irrespective of whether you're provisioning workloads from the vCenter API or from the Kubernetes API, they can coexist within that environment, right? So you don't need to have two different clusters, one for Kubernetes, one not. No, you can take existing environments with Project Pacific and run both regular vCenter VM-based workloads and Kubernetes-based workloads side by side. So that's the really cool part about it, right? So you can move some apps over, you can keep some as they are today. You've got a lot of flexibility, a lot of optionality with this solution. All right, so let me introduce a couple of concepts here. So we have that VM, right? This ability to run a whole bunch of workloads inside this VM. This is the same basic architecture picture I just showed a minute ago. As I said, we can now run Kubernetes clusters. So think about this as a Kubernetes service. The idea being that you can actually run PKS, or if you're an OpenShift customer, there's a bunch of different things you can potentially do there. But why would we do this? Why would you have Kubernetes as a supervisor cluster and a guest cluster? So there's a few reasons for that. The first of which is that oftentimes people have various version requirements on Kubernetes. That different apps, especially from different vendors, may require different versions. And so having the guest cluster is nice to be able to have that version. These guest clusters are really focused on 100% upstream Kubernetes compliance. This notion of there's a specific set of tests that prove that cluster is compliant, and if you run a workload there, it can be moved to any other Kubernetes cluster anywhere else, on a public cloud or something else, right? We do some tricks at the supervisor level, so we fail a few of the tests. But some people who are purists, want that full compliance. And then there's issues around, you maybe want extra security, extra isolation, and so on and so forth. So there's a lot of reasons why we think people will use this Kubernetes service. And the cool thing about this is that making investments in PKS today still work here, because PKS is a great guest cluster in this architecture. And so again, you look at these guest clusters, this Kubernetes service. The Kubernetes service is about Kubernetes. It is about delivering Kubernetes as a container orchestrator, right? The original intent. With the supervisor cluster, we're really leveraging Kubernetes as a means to an end. We're leveraging it as an infrastructure abstraction, as an infrastructure interface. So there's a little bit of different purpose there. that comes out. We talked about the VM service, right? You can run VMs, any type of VM you want. Really powerful, very cool. And you can also imagine application services as well. I talked about this before with that HANA database, right? Rather than having to individually provision all these different VMs and configure it, wouldn't it be cool if we could integrate with various ISVs, Kubernetes operators, to actually provision their workloads in this environment, and to do so in a very prescriptive way that's driven and owned by that vendor. So really, I think we're still at the very tip of the iceberg here. This is some really, really foundational and transformative technology, but really just at the beginning of what we can possibly do. So kind of to summarize really quick, and then I'll get into some screenshots so we can actually see what this thing looks like. So again, this developer has an API interface access to either the guest cluster or the supervisor cluster or both. What the supervisor cluster is enabling is kind of infrastructure as a service. This notion that an IT admin can actually create a namespace for a developer, then they can get self-service access to that infrastructure is very, very powerful. And they can go off and do a whole bunch of cool stuff. On the IT ops side, there's a bunch of goodness here too. We talked a lot about service management, we talked all about workload management, managing this stuff at scale, and of course getting integrations to all the great features and functionalities that we have today. So if you're a VMware Cloud Foundation customer, you have NSX and vSAN, we can take advantage of that. There's a lot of really cool work NSX is doing, or the NSPU is doing with NSX and integrating that into Kubernetes. And so we can take advantage of all that great stuff. There's really cool stuff that our vSAN team is doing, the storage team in general is doing around their cloud native storage effort, and providing a whole bunch of really cool functionality to make persistence, data persistence, super simple and enterprise grade for Kubernetes environments. So this really is, not just a vSphere story, it's really an SDDC story as well, and it just gets better as you have VMware Cloud Foundation. Okay, so let's go to the demo, and then there'll be time for questions here at the end. So this demo is really just a set of screenshots. We wanted to just sort of take it slow and point out some things. So I want to go across 3 different axes here, the provision, build, and manage. So we'll start out from the point of view of an IT operations person. We're here, we're in vSphere, just like the vSphere client, just like normal. Now, you will see some differences here from what you're familiar with, right? We have, what do we have here? We've got some clusters, okay, we understand those. We've got some hosts, and oh, here's a namespace, right? This namespace is interesting. So we have a couple different namespaces, a couple different namespaces, or maybe just one. The work auth app and then this finance app. So within those namespaces, we can provision various sorts of workloads. You can set various sorts of policies here. You can see, basic status on it. Is it running? What's happening to it? Permissions that are set, so on and so forth. So if we go into it, we can set, let's say, some permissions. We can give a group of folks, in this case, the team that built this thing, access to this environment. We can set limits. We can use various resource management settings. We can do storage policies. So again, this is stuff that you're used to. This is stuff that looks and feels just like a VM or anything we've traditionally done in vSphere, except we're now doing it to a Kubernetes environment, specifically a particular Kubernetes namespace. And so as we've gotten this thing all set up, we can now see a whole bunch of stats. Okay, the storage is all set up, we're ready to roll there. So when pods get created, we know where to go get storage from. There's a bunch of permissions as to who can do what with it. Resource limits, so we make sure that this namespace doesn't overwhelm all the other namespaces and VMs on our system. So this is standard vSphere stuff, right? We know this. Okay, so this was kind of job number 1. That you as an IT administrator, as a VI admin, go in and create that namespace, set up all the settings, and then you can give access to your users. And then the user will go in and they can download, they can integrate, or excuse me, access Kubernetes how they wish, API calls, CLI tools, etc. Here we'll show a CLI. And so in this model, they authenticate themselves, and they can start doing their usual Kubernetes work. If you're not familiar with Kubernetes, essentially what we have here are these different YAML files. Again, these are the declarative specifications for different workloads. And so you can see here they're doing a few things, right? They're saying, hey, go run a Kubernetes cluster for me as spec'd out in that YAML file. Go create some native pods for me, and go create some one or more VMs. And so again, they're using Kubernetes. They don't even see it's vSphere. Isn't that interesting? As I mentioned before, to the developer, this looks and feels like Kubernetes. This is what they're used to. This is what they do on a day-to-day basis. The fact that it's vSphere, they can know that in their head, But from an tooling standpoint, they can use the tools that they're familiar with, the tools that they want to use, and move at the speed that they want to. And the cool thing about this is a CLI view here, but the Kubernetes ecosystem is massive, as you probably know. There's a ton of different tools working around, how you build applications, CI/CD processes, these sorts of things that all integrate really seamlessly with Kubernetes. A bunch of infrastructure orchestration tools integrate seamlessly with Kubernetes. So once you've given access to that namespace to the developer, they can really go to town doing stuff as they wish. Okay, so now the developer's gone and provisioned a bunch of stuff. So this is cool. So as you can see now, we've got some pods running. I got 57, it looks like. You can see some different stats over time. We've got some storage being used, right? Some different persistent volume claims there. We've got, what else do we have here? CPU and memory usage. You can see the CPU's actually got the limit that we set earlier. So again, a lot like a VM, except the difference now is that it is actually a Kubernetes namespace, and it will be a collection of VMs or pods or Kubernetes clusters, etc., running inside of it. And then we can actually go down to a deeper level of detail here. If we go down to the Kubernetes cluster itself, we can see a whole bunch of details there about what that cluster is doing. Again, we get this visibility into Kubernetes that we haven't traditionally had before. Today in vSphere, what you would see with a Kubernetes cluster running on it would be just a set of VMs. You wouldn't even know it's a Kubernetes cluster. You just see, VM XYZ. But here we can get inside. We can actually see what's going on inside that guest cluster. And that's, I think, the other important point here. I mentioned before this ability to run VMs, but this is more than just a VM. We know contextually that it's actually a Kubernetes cluster, and that's how we represent it inside of vSphere. So we actually made that a first-class object, which is super interesting and super cool. So we can explore, and we can see all the different resource limits we've set, look at who has permissions for what, look at different sorts of policies, storage policies, etc. that we've set. Again, a lot of familiar stuff. What's also cool is that we can integrate with the Kubernetes master to pull out a whole bunch of information. So like different events that are occurring or so forth. And give you that visibility, again, from the vSphere client. So the broad theme here is that this allows our VI admins to start playing and getting used to Kubernetes without necessarily, or I should say by staying in a tool they already know and use every day, right? And using all the different tools around that. So really, really powerful stuff. Now, as Pat and Joe outlined this morning, this is part of a much broader narrative here, right? It's not just about Pacific. It's what we're doing with Pivotal, what we're doing with Bitnami, what we're doing with Tanzu Mission Control, like the overall Tanzu vision here, and of course the PKS as well. And so as I mentioned, PKS is available today. It's a great way to get started. And really what we're doing here with Pacific is supercharging vSphere with Kubernetes to enable all these great things we just talked about. And so another really cool aspect of this, as I mentioned, is that while this is a technology change we're making, we really think this will drive greater changes in the industry as well, right? I talked about this notion of all of our customers potentially being able to move their applications over to Kubernetes, right? 70 million apps in the world over to Kubernetes. That's really powerful. And helping you all to embrace Kubernetes and really move forward and take advantage of all these really cool things happening in that ecosystem. The thing I haven't mentioned yet are partner tools. And so partner tools are interesting because they speak the vSphere API today. Some of them may speak Kubernetes. But the ones that just speak vSphere, that API will also light up and have visibility into some of the stuff that's happening on the Kubernetes side, right? They can see these things running within ESX. And so a lot of those tools will now just start working, things like vRealize operations, or backup software, whatever it is. You can start taking advantage of that, leveraging that for these newer workloads as well. And so it's one of these things about, how do you take advantage and leverage all the investments that you've made over these last many, many years on top of vSphere. We can enable you there as well. And obviously all our partners are very interested in this. They want to integrate with Kubernetes natively, but this is a good way of accelerating that to get some basic level of functionality. They can then come back and add on a whole bunch of more cool stuff on top of it. So, I've got a lot of time for questions, so we can definitely get into some Q&A here. But I also highly recommend you go check out this other breakout session we have for Pacific on Wednesday. This is going to give you a bit more technical depth. We also have a demo station in the expo hall. We have a bunch of stuff online as well, blogs, website. We have a live stream on Wednesdays to go into even more detail here. And so this is a long time coming, been hard at work at it, and that we're really excited to share it with you all. So Now let's do some Q&A, and I think we're changing it up a little bit this year. Instead of having microphones placed around, we actually have people who can take a microphone to you. So if you want to ask a question, please raise your hand, and they'll run a mic over. Looks like there's one over there. One person appreciated my talk, yeah.
Just a quick one. That management view, does that extend to vCloud Director?
That's a good question. So today the main focus initially has been on vSphere. Obviously, so one of the things I should have prefaced at the beginning, this is announced as a technical preview, so obviously we're not making any commitments in terms of timelines or anything. But certainly we want to look at how we can make sure that all the different parts of the VMware ecosystem can plug into this properly. Okay.
So I guess I kind of stole my thunder. I was kind of wondering when exactly we were expecting this specific version that you're targeting for vSphere.
What can I say? We have plans.
19.
We have plans. I'll put it that way. We can't give any specifics on timing, unfortunately. There's one over here.
Where?
I had a question about scalability. This looks like it's going to have a pretty significant impact on vCenter.
Yeah.
And what are you doing to vCenter to be able to handle that much more traffic and activity and whatnot?
That's a great question. Yeah, so this is actually really cool. There's been a bunch of work happening across the vSphere team in many different areas, and they actually are highly complementary. So one of the things we've been working on with vCenter, is a number of things. So first of all, there's scalability issues here, to your point, because we got like tons of containers and pods and all sorts of chaos happening, things starting and stopping. The other scalability issue actually comes from Project Dimension or VMware Cloud on Dell EMC. And VMware Cloud on AWS as well. This need to have more and more SDDCs kind of everywhere. And how can we really transition vCenter into a system that's designed to be a distributed system? vCenter is a distributed system, but I think historically we've been focused kind of on single server scale up type models. And so where that team is going really is driving toward more scale out type models. So I don't know how much I can talk about publicly, but there's a bunch of work we're doing to deal with a lot of those scalability in both those dimensions. But it's a great question, right? And you're absolutely right. This goes back, by the way, to the point I mentioned earlier, where this has been, a massive team effort on all sides in order to make this thing work. Other questions? There's one way in the back there. And there's one here as well.
Yeah, regarding the API interfaces, so you've got the Kubernetes API and then the vSphere. Do you ever have any problems with kind of an intent conflict since they're both consuming from the same resource pools?
Yeah, so that's a good question. So in terms of the resource pools, in terms of the actual cluster itself, provisioning workloads, that doesn't change at all. Like today you could have the same sort of issues if you had multiple users using the API to provision workloads within a cluster. You might always have that sort of overcommitment or whatever. And vSphere can deal with that just how it normally does.
You had a question?
So that's not too much of an issue that we've seen. Yeah, okay, one in the back there.
Yes, sorry. I just had a question about the guest cluster and the supervisor cluster.
Yep.
You mentioned that the guest cluster is conformant to,
Well, it can be.
CNCF.
It depends on whose guest cluster, who's provisioning it and managing
Right.
it. But yeah.
Okay. But is the supervisor cluster conformant, or is there plans to make that?
It is not 100%. Again, because, and this comes down to architecture. So fundamentally, ESX is not a traditional operating system, right? We're not running traditional processes for these pods. We're using the CRX. It's basically a virtual machine, but again, we kind of modified to look a bit like a process. So there's a few things a few tests we don't pass there. I don't know the exact numbers, but we're pretty close, but it's not 100%.
Right here.
Okay.
Yeah, my question is, how will you deal with the Kubernetes release cycle?
Yeah. Yep. So that's a good question. So we've made it so that we can update independently, and we give you some control. Update independently of the normal vSphere release, but we also give you controls in terms of how aggressively you want to update. So I forget the exact N-2 supporter or whatever it is with the Kubernetes version. So if some people want to be on the latest and greatest, they can do that. Some people want to kind of hold off a little bit and move at a different speed. You can do that as well. But yeah, so and then as I said, you can also run a guest cluster, which gives you some flexibility there in terms of version as well. There's one up here.
So we use vCenter tags quite heavily through a lot of the other operations tools.
Yep.
The question is around the Kubernetes constructs, right? The namespace, the labels. Will those start to supersede the vCenter tags or be used in addition to them?
That's a good question. I don't know if you guys over here have more thoughts on it, but generally speaking, I mean, the Kubernetes labeling system is pretty powerful, right? And so I do think there's a lot of leverage we have there. I don't know if have we done thinking around how we can merge those two?
Yeah, we're not merging them right away, but from the Kubernetes side, you get full label and selector functionality and everything. So to your DevOps team, they can use all that. And some other tags and things like that are kind of cross-pollinated across the systems, but there's not a full one-to-one mapping in all cases.
So and I guess maybe it goes to, we might take it offline about your existing or your exact use case and how you're leveraging tags. Certainly, as part of, if you let's say you took an application today that's you managed via vSphere and move it to be managed via Kubernetes instead, you could obviously manually move over the tags to be labels there. Then the question is, where do you want those labels to proliferate to? What tools need to see those things? And so that's, I think, some of the more detailed areas that we need to work through, right? Okay, one back here.
Is the networking consistent now between the containers and VMs? I'm assuming using NSXT, but from a developer perspective, deploying both containers and VMs, is it like a smooth interface to them?
Smooth interface. Sorry, I don't understand.
So is the networking constructs between containers and legacy VMs consistent?
Yeah, absolutely. Yeah. So we can leverage NSX to do that. And as I was mentioning, NSX has got a bunch of cool integrations they can do. So you can actually specify what network you want to use inside of the YAML specification for an application from Kubernetes. And we can automatically wire that up for you. So that way, yeah. So even if you have VMs and pods running inside of specified via Kubernetes, or you have some existing VMs just running as normal VMs and pods here, yeah, the networking is all aligned now.
How does the security patching and vulnerabilities work?
Security patching and vulnerabilities.
So basically, if I have vulnerability on Kubernetes side, and now I have ESXi, how does they kind of interface with each other or dependencies and all those things?
Well, you can just patch it, like you do normally for ESX. So
it'll be independent of Kubernetes can be patched on its own and ESXi, or it'll be ESXi, which is your patching, and that will take care of the Kubernetes vulnerabilities.
I think you can do both, but Mark can explain.
Yeah, so there are a lot of elements of the system to worry about patching. There's ESX and vCenter, and then there was that Spherelet component and the CRX component and their guest clusters. So kind of the story depends on which layer of the stack that you're talking about. But in general, your supervisor layer updates are delivered via patches to vCenter, and then those get deployed kind of asynchronously from your vSphere updates. And so you have some optionality over when and how to apply them.
Let's see, there's one over here and then one there as well.
I'm gonna go. Yeah, I have to go back on that side. I gotta go back that side.
Thanks.
Mike.
So, just listening and reading a little bit between the lines, Kit, I want to make sure that I understand. It's sort of, you made it sound a little bit like you have to have NSX. Is that correct?
We are working through some of those details now.
Okay.
Certainly NSX makes it a lot easier. Right?
Oh, I agree with that, but I just know a lot of customers that will not really like that.
Yeah, so, and then there are options, by the way, of not using NSX. Like we can use open source networking solutions there as well. So those are some, so again, the fact it's a tech preview, we can't say specifically on some
Understood.
of those things yet.
And then the last part was just related to the patching and updating and all that. I really hope that it all is done with Update Manager.
So on that note, this is there's a lot of evolution of vSphere happening, and one of the big things we are looking at is how we can better manage, host, ESX in general, host configuration, patching, updating, and so forth. So there are Again, I can only say so much publicly here, but there's a bunch of work we're doing to dramatically simplify that and evolve where we're going with Update Manager and so forth.
So that's the second time we've done that.
The second, well, this time, this is exciting stuff, man. It's a little bit different than that first time, all right?
That's good, actually.
Yeah, you know too much history. No, but it's really cool. And so the idea is, again, on this Kubernetes mentality of being declarative, how can we make ESX configuration declarative? And some really fundamental stuff like, well, anyway, I shouldn't get into it. I want to get into it, but I shouldn't get into it. Good questions, though. There's one over here.
So back to the kind of the networking piece, integration into VR and I, and the ability to see between the Kubernetes workloads.
Yep.
So will we be able to see, let's say we've got several of these running within the same, not just cluster, but on the same host. Will we be able to see that traffic, the flows from one to the other in a deeper introspection to that? So you can see this is communicating here, this is communicating back, et cetera. Because before, a lot of times when you've got a physical kube device, a host, with that in there, it's very hard to sometimes see that traffic.
Yep.
Okay, that's to make it better. And the other one is kind of follow-up is integration to other things. So can we dump out from those workers, can we dump out things to log insight?
Absolutely, yeah, for sure.
That'll be good.
Yeah. I mean, look, so one of the things we're doing, another big kind of meta thing, if you take a step back, historically, our focus with vSphere has been we want to work with any sort of guest operating system or application that you might have. And that's one of the really big benefits of things like vMotion or DRS or HA or snapshotting. It just works. It doesn't matter if it's like Windows or Linux or Solaris or what sort of workloads running in there. And so we treated the VM boundary as a very special thing. We generally speaking, didn't go inside the VM too much, right? Okay, yeah, we had tools and a few other things, but broadly speaking, we kind of looked at the VM as this black box. The biggest change here with Kubernetes is that we're now getting inside that black box, right? We're getting that visibility, as you saw from some of these screenshots, getting deeper visibility than we've ever had before from the vSphere client. And we're able to do that because of the fact that Linux and Kubernetes are really becoming standards in the container ecosystem, the container world, right? We can sort of build that stuff in and make some assumptions there that these things are used and then get that extra visibility. So yeah, so that question around network visibility, all that stuff starts to play out here. Other question, there's one here in the middle.
Thank you. I was just going to pass it.
Yeah, so I just have a general question about obviously the whole, if you look at VMware's main sort of competitors and stuff nowadays, like obviously it's public cloud providers, and the sort of main benefit of running in a private cloud or public cloud is managed services and serverless and all that kind of stuff. I'm assuming that this direction you're going is not only to be able to run like Kubernetes and stuff, but actually to be able to run managed services and these kind of stuff on there. I was wondering how you guys are thinking about that, if that's like a partner, or like VMware developing their own services.
Yep. Yeah, and that's kind of where I was going a few slides back with those. Actually, that architecture slide that showed the Kubernetes service, the virtual machine service, and then application services. And so that's the idea there, right? This idea of, could you get, I mean, maybe a HANA database is a bad example, but HANA database as a service, right? Or, Redis as a service, MongoDB as a service, these different sorts of things. The cool thing about it is that, again, with Kubernetes, there's this concept called an operator. An operator is not just the content of an application, but also rules for how this thing is run and how to do various actions and operations. And that's all kind of standardized with Kubernetes. And what you find is that many of these ISVs have those operators. And so that's the other great thing about embracing Kubernetes is there's a massive ecosystem, people doing this work, and now, hey, now we have this interface to Kubernetes. We can layer on a bunch of those things and start getting this really diverse set of services on top of vSphere, wherever vSphere happens to be. And so this is why if you look at all the different things VMware is doing, they really add together in really, really cool ways, right? With AWS, with Dell EMC, delivering stuff as a service on-prem, what we're doing with Azure or Google. These are all delivery mechanisms to get vSphere to as many different places as possible, Simultaneously, with things like Pacific, we're actually changing the nature of what vSphere is and delivering more value with vSphere. And now we can start adding these other things on top, right? So a lot of, and then at the same time I mentioned all the different architecture work we're doing internally to this as well. So yeah, so a lot of really cool things are coming to fruition, right, over the next little while here. We're seeing some of the things now, and we'll see more soon. So it's a really exciting time, right? I think that we're, again, just kind of the tip of the iceberg of some of the really cool stuff we can do here with Pacific. One more question back here.
I had a question about the kind of the operational impact that you're implying. Not a lot of organizations that I interact with have the vSphere administrators and the Kubernetes cluster management group be the same group.
Probably no one does that today. You're right.
So what you're doing is you're kind of elevating the responsibility of the vSphere administrator to now be the Kubernetes cluster administrator as well.
Yeah.
But they've also already become the storage administrator and a bit of a network administrator at the same time.
Yeah.
So this is kind of changing operations. Within ops groups. And I'm wondering what VMware is doing, or whether or not they're talking about what kind of impact that's going to have on customers who whether or not the existing Kubernetes cluster management group is going to want to relinquish that to the vSphere administrators, or how they coexist. The personas, really. What's that look like?
Yeah. So that's a great question, and we do think a lot about it. And I think you're absolutely right. Look, I mean, one of the other big aspects of this, kind of, I think I mentioned a slide or two back on this one, was how do we take our customers on a journey as well? We think a lot about career growth and career trajectories for our VI admins, people who have dedicated a sometimes significant portion of their lives and their working life with vSphere. And how can we take all that investment and move it forward? And so this is absolutely part of that. And you're right. vSphere started off as this compute thing, and now with the SDDC, there's storage, there's network, it's all plugged in, there's automation, getting into some security stuff, end user computing potentially, and now Kubernetes as well. And so I think what I see first and foremost is optionality for customers. And by customers, I actually don't mean businesses, I mean individuals, right? You as an individual, what does your next 5 years look like? Where are you going? Like, where do you want to do? What's the role you want? And what we're doing here is making it really easy, or as easy as we can, to get up to speed on this brand new technology, which maybe a lot of people hadn't really looked at much before, hadn't really been able to figure out. We can now give it to them in sort of terms and environments that they're familiar with. And so that sort of career growth and progression forward is a major aspect of that. Now, your question of well, how does an individual deal with all these different responsibilities? That is a great question. I think it's this concept of how can you be this kind of lifelong learner and do more and more. And we're also looking at it how can we continue to up-level? And so what you're going to see is that this application-focused management, that's a type of up-leveling. So you spend less time getting into the nitty-gritty of every single VM or container. What we're doing with VMware Cloud on Dell EMC, VMware Cloud on AWS, we are seeing a proliferation of SDDCs. And what we have now is what we call this cloud console that you can use with both AWS and Dell EMC, and eventually with all types of SDDCs, to be able to get a higher level vantage point. And we think that over time, you might spend less and less time in vCenter itself and more time in this new thing, because that allows you to manage more at scale, right? And so there's a long ways to go to get to all that, but we're definitely looking at how can we invest in terms of the tooling and technology to enable our VI admins who have so much more responsibilities to be able to handle all those responsibilities. So, there's a lot to do there, but we're definitely thinking a lot about it. This is a great question.
Hello? What about the licensing? So basically I expect that it will be like vSAN, separate license, so you license your cluster separately, so you have the regular vSphere, the vSphere plus vSAN, and then another kind of key to enable the Kubernetes features?
Again, because we're in tech preview, we're not talking about any specific licensing or anything like that. So we'll talk about that once this is GA'd. Did you want to say something, Dilpreet?
Yeah. Zip.
I think it's important to understand that while we're increasing the role for what the VI admin can do across the infrastructure and do management of the infrastructure really well across a set of things, we're giving a dev and a DevOps the ability for the instantiating pods and clusters. Now, that's where the Tanzu Mission Control comes in, where you can then use Tanzu Mission Control to be able to manage a set of those clusters. So whether or not VI admin actually manages those clusters is really a choice in your organization rather than something that we're sort of mandating in one way or another. I think how you manage your Kubernetes cluster deployments versus how you manage your infrastructure are two distinct things.
That's a great point. Now, that was the second part to his question that I failed to answer, so thank you for that. I got going on the VI admin thing. Got all excited. Any other questions? All right, well, you see all the other activities here, so please take advantage of them. Go to the breakout, stop by the booth, read the stuff on the website. Thank you, guys.